Right, can you see my slide?
Yes, sir.
Enter.
Right. Okay, Assalamualaikum and very good morning everyone. Dah breakfast dah? Belum lagi?
Not yet.
Not yet. Alright. Okay. So first of all, so this is the second lecture that we have for this week, and we're gonna cater on the third chapter, which is on the chapter 3. It's on sequential logic structure, right? So hopefully you already download and try to read just a little bit on this chapter, because this chapter is there is a lot of things that we need to cover, especially regarding the how we can design our logic structure by using the PAC, IPO, and other things like a flowchart, pseudocode, and algorithm as well. Right? Can you hear my voice clearly? You can just type in the chatting if you can hear my voice. Right? Okay. So this is a what you call it, the outline of this chapter. Right, so we're gonna cover on the introduction to sequential logic structure. Actually, what is sequential logic structure? And I can say that in the programming, right, so you need to have a good logic thinking here, in terms of how you can try to solve the problem. Right, later on we're gonna see what is a PAC, right, what is IC, and also what is IPO. We're gonna use this kind of the what you call a solution development here. This is what we call a solution development. Right? And then we're going to cover on the pseudocode and also algorithm. We're going to see what is the differences between pseudocode and also algorithm. And then we're going to have checking here, either the pseudocode and algorithm that we have is good enough, right? Is efficient enough. And then we can use this testing by using a test checking. All right, and the last one you're gonna cover on the flowchart. You can we finish our lecture until flowchart, and then we can cover for this one, right? Okay. So introduction to sequential logic structure. So what is sequential logic structure actually? All right. So the meaning sequential here is like a step by step, or other things is like a process the instruction in sequence, okay, from the top to bottom and algorithm. So meaning that we need to have the start process and also the end process of the algorithm or the program as well, right? So and then this is one of the mostly used and simplest logic structure in programming and also in problem solving uh, domain. Okay, and then most problem use in combination between one or more or other logic structure. So meaning that you can use either PAC and IC together in order to try to solve the problem. Some cases or some people, some programmer use only algorithms. Some programmer use only pseudocode in order to understand the logic structure of the program itself. And some of the documentation, they use a combination all of it. Maybe they have algorithms, pseudocode, a flowchart together in order to make it more understandable for the other programmer, right? Okay. So what is PAC, IC, and also IPO here? This one is a short form for the all these terms here we have here. PAC means that we have a problem analysis chart. IC is an interactivity chart, and also IPO is a input process output. And this chapter we're gonna cover all these three, what we call a solution development, right? So the aims of this subtopic is to analyze the problem by using the problem analysis chart. We're gonna see what is the analysis chart here, and then we're gonna have some kind of the case study, and then we're gonna map this case study into the analysis chart. And then we're going to set up the most efficient solution by using interactivity chart, right? So this one is looks like a diagram. Okay, there is a one module, go to another module, third module, and so on. All right, like interactivity for the particular program, right? And the third one here is use an input process output. So meaning that we're going to apply this IPO chart to designated the input process, module number, and also output for a solution of a problem. All right. Whenever we have a PAC here, we already have PAC, and then together with the IC here, then we can use the IPO, map it into the input process. Module number is based on the interactivity chart that we have here. And then we have the output for the expected output of the program. All right. Okay. So what is problem here? So problem we call as a we can separate it into three components here, three main components that should have the input, okay, and also have the output. So in order to get the output here, we're gonna have the processing, like what you call. Let's say I give you some example here, a problem how to calculate two numbers here. All right. Of course, there are two numbers that you need to input here. They need to enter in the program, right? And then the output should supposedly the addition of two numbers, something like that. All right. Let's say the input is 1 and also 1. So the output supposedly is 2, right? Right. Okay. So the processing here is like it's a mathematical formula plus it's an operation for it, and then we have the operand, first number, operator, and then for the operand number 2, like that, right? Okay, so this one is very basic of the problem here. Later on we're going to see there's a problem case study that you need to extract all this information, input, output, and also processing, right? Okay, so we're gonna direct through on the PAC here, right? It's a problem analysis chart. Right. Okay. So according to this book, all right, 2012 by Frankel and Humbert here. So PAC here is called initial step for a program need to do when a problem is to analyze and understand the requirement. So meaning that this is one of the requirement in to do for the development part. Okay. So some of the company they use this kind of the the solution development by using the PAC here. So there is what it calls 4 sections in this chart actually. All right. The first one is the data. The second one is the required result. And the third one is what kind of the processing involved in this problem. And then we can list out what are the potential solution for it. Okay. If you remember regarding our first chapter here regarding the 6 step of the problem solving, there is one step that we call list out the what I call the potential, the possible solution for the problem, right? We're going to apply this one in this PAC solution problem. All right. Okay. So this is one example of it. Okay. So this example show 4 section and how PAC looks like. Okay. So we have 4 section here. Section number 1 here is a given data. Whenever I give you a case study, you're gonna extract what kind of the information, what kind of data is suitable for this problem. All right. And then what kind of the result, required result here means that the output. Okay. And then the third one here is the processing required. The last one here is the solution alternative. Solution alternative means that there is no fixed solution for the problem. You may have a certain of the alternative here. For example, like we have two numbers, addition for two numbers here, right? You can set the numbers directly to the variable name, like say for example, x equal to 10, y equal to 10 as well, okay? And then you do some calculation here, x plus y by using a variable. Some of the alternative here we can use like enter first number. You enter a number, right? Instead of you directly put the fixed value or the constant value into the program. Okay, enter number 1, enter number 2. There is another alternative. Another alternative is that you set the number into the program itself. That's we call as a constant value. Right. Okay. So this is an example, all right? So this is an example. Let's say we have a program to record the find average of 5 numbers. Okay, 5 numbers. Okay, so based on this problem here, what is the data? Can you type up in the chatting here? So I want to make sure that you follow my instruction. Okay, so what is the data? So and then what is the what you call the output, the required output from this case study, and then what is the processing for this one, and the last one, what is the alternative solution for it. Okay, so as you can see here, this is an example and already given the solution for it, the given data, required result, processing required, solution alternative, and right. Okay, so the given data here is numbers, right? As we can see here, a program is required to find average of 5 numbers. Okay, so try to look at on the text that I highlighted here with the yellow color here. There is very important information that you need to extract from this one. Find average, it is the important part. 5 numbers here. So 5 numbers here, you can set it as a given data, right? Is a given data. You can set here as a number 1, 2, 3, 4, 5, something like that. Okay, so that is like data that we have. Let's say you have a 5 average of 100 numbers. How we can do that? Is it you write down numbers 1, 2, 3, 4, 5 until 100, right? There is another way that we can set here the given data. Here, so let's say you can set here number 1 until 100, until 100. So we know that when a programmer do something like a programming technical part, they know that okay, this program requires 100 numbers. Okay, instead of we have a very small numbers here, 1, 2, 3, 4, 5. Okay, right? So then we have a result. The required result from the program here is the average of 5 numbers. Okay, normally we have a case study, then we have an end result for it. Okay, so it is the average of 5 numbers. You cannot say it's an average. Okay, it's an average here. It's not clear enough. Maybe the required result here, given data we have 5 number. If you put here average here, it means that do you want to average for 2 numbers only, 3 numbers only, 5 numbers only, and so on, right? You need to be clear regarding this kind of the section here. Required result is very specific, average of 5 numbers. Okay, and then we have a processing required. Okay, so of course this was a very simple mathematics in order to get average of 5 numbers, and then we have a total equal to 5 numbers. Okay, and then we have a total summation of 5 numbers divided by 5, and then we have the average of 5 numbers. Okay, and the last one here we need to consider regarding this one is solution alternative. Okay, define the numbers as constant. So this one is another alternative here, meaning that number 1 is set here the fixed value, let's say 10, number 2 here is 5, 3 is something like that, and so on. That's why we call it as a constant here. Okay, so define the numbers as input values. What is the meaning of input values here is that, okay, when you run the program, you are the one key in the user are key in the numbers here, 5 numbers. Let's say enter number 1, enter number 2, enter number 3, 4, 5, 6, 7, and say like that. All right. Okay. Can someone justify me? There is one character here, or you can say that there is one symbol here, is asterisk symbol here. That means something here. Can someone try to give me the answer for it? Okay, boleh sesiapa yang justify what is there is a strict value, there is asterisk symbol here. Okay, anyone? Ada sesiapa? Okay, if you go through my notes in the ebook here, chapter number 3 there, okay, there is a there you can find the answer for it. Okay, this asterisk symbol here means that this solution is the best case for this one, right? It's the best way for this solution. Define the number as input value, meaning that, okay, if you choose this one, you run the program with by using a different numbers instead of you set as the constant. You run the program, there is only numbers that you got. Okay, right? Is that clear? If you clear, then you type down a yes in the chatting there. Right. Okay. So this one is a example for it, and then supposedly that you need to try this one. Okay. So program is required to find volume of cube. Please construct the PAC for this problem. All right. Okay. So this one is I'll just leave it to you just to go through what is the solution for this one. All right. Because we have some kind of the example on the example number 1, and I can say that starting from chapter 3 here, there's a lot of question in the midterm and also final year. All right. Okay. Means that it's important for you to understand this one. Okay, so you can say that this one is the answer for it. Okay, the given data is the age and also a here. All right, so we have a age required to find the volume of cube. Please construct the PAC for this problem. Right, the required result is the volume of cube. Okay, it's a volume. It's a volume. So you need to have 3 edges here, right? 3 edges here. You can set here edges with a variable a, so means that enter edges. So we have 3 a's here. So 1, 2, 3, and then this one will be the variable that's which holds the value of the volume. All right, the solution alternative here we have a tools here. Define the age as constant. Okay, the age as constant. A, B, A here is equal to a numbers. Instead of we define the age as input values, which have only a flexible number. Whenever you run the program, you can set or enter a different number to get a different volume result. Right? Okay. So this one is an interactivity chart. Just now we look on the PAC. All right. It's a problem analysis chart, how we can extract the information from the case study, right? And then we move on the second part here on the solution development, which is an interactivity chart, or we call it as an IC. Okay, so this one we are dividing the processing into subtasks that we call as a module, right? It's a module. Later in the next topic, you will see again this term of module that will reflect to the function as well. Okay, so here we have main module and sub module. Of course, we should have the main module that we call it the parent module here, and then we have a child module and so on that will do the specific task for it. Okay, so main module controls the flow of the sub module. That's why I said it's a parent. Okay, that's why I said it's parent. It will control all the sub modules underneath of it. Okay, and then it's connected to show interaction of process between module, and then it should be, let's say this one is the parent module, then you have an arrow for it, 1, 2, 3, and meaning that this arrow considered as the interactivity of process from the parent to the child module. And then we have each module's content task to accomplish, again task to accomplish. So this one means that this one, each module have a specific task. Okay, this task may do some just to read 2 numbers, and this task again, this module just to do the calculation part, and this module to do for to display the output of the addition of 2 numbers. Right? Okay, so there are 2 ways. Okay, there are 2 ways of writing a solution by using interactivity chart here. The first one that we call it procedural programming, and procedural programming you will touch more on the problem solving and also the programming technique, okay, for this chapter. And then you have another term here that we call object oriented programming, and object oriented programming you will see again this one in the Java programming, which is a subject is more specific on the object oriented programming. You will use event driven solution. Okay, so but this one for problem solving and programming technique, you will touch more on detail on the procedural programming, which is type of writing a solution is one of the type, and this one is top down method. Whatever is called top-down method, it means that it's step by step, step one until at the end. Even event-driven here is different. It's totally different compared to procedural. It can be jumping to the other side and so on. Okay, and procedural programming, the module only process the task that connected to it. So meaning that, okay, whatever this module have, we call for this module, and then it will be implemented. Whatever you write down this module in the program, but you didn't call this module, so means that you don't implement this module, even though it's already in the program. Okay, right? Okay, so this is example of it. Interactivity chart that we call as a procedural programming by using procedural programming here. And then we have a control module, or we call it as a parent module. And the number of the module here is 000. Just to be clear regarding this one, is just a numbering for the module number, right? And then underneath of this control module, we have a sub modules. We have module 1, 2, 3, 4, and 5. And each of this module we call as a sub module, and it's do specific task for it. Module 1 do this one, module 2 is 3, this one 3, and so on. Right? Okay. Right. So we have a control module. This one is a description for it. Okay. So control module processing of all the data. The chart is displayed in top-down method. It means that you divide the problem into subtasks. If you have a large program here, you should have what we call the main module here. In the programming, we call it the main function. This one. So inside the main function here, you have sub function that you should have in order to do the specific task, right? So sub module here, the next level of rectangle starting with number 1000, 2000, 3000, and so on, and increase from left to right by increment of 1000, right? Okay, we try to look on the previous slide, and you can see here the control module is starting from 000. So meaning said the programmer sees that this one is the parent module, and then it start from the left side here, starting from 1000, and then go to the right side, we increment 1000 as the numbering for the sub module, right? Okay, the last one here, sub level module. We have a sub level module here. The next level of rectangle starting with increment of 100, as is 100, 1100. For example, the sub level module here is under module number 2. Starting from the numbers is 2000. So 2100, we know that this is the sub child of the module 2. Okay, right? If you have here a child again under this module number 3, here you have a sub level here, which is 3100, 3200, and so on. All right. Okay, if you understand this one, okay, you can type down yes in the chatting, so I know that you are following my online lecture. All right, so this one is more detail regarding the IC here, which is the procedural programming again, but this one we have some kind of the a shape here, okay, like a shape here with a rectangle shape here, and also the bullet shape here, right? So we have a control module. Each one is the task processed by the module, meaning that the interactivity between the control and the modules, right? This one, the bullet here, we call it a looping. Okay, so meaning that module 3 will have a looping key here. Okay, we have a looping here. And then we have like a diamond shape here. Okay, so this diamond shape here refer to the decision. Okay, refer to decision. You will see again this shape in the flowchart at the end of this lecture, right? And then we have here the black rectangle here. So you consider as a duplicate module. Whenever it's duplicate module here, it's made refer to module 1 and also module 4 here. They have the same task. Okay, let's say this one addition. This one we're gonna use the same module again in module number 2 to do the addition in the module 2 here. submodule under submodule number 4, right? Okay, so this is an example for it, for the tuition fee control here, right? So under the tuition fee control here, this one is what we call the the main module, and the control module as a control module. This one is a control module, and inside this one is we have a read number. Okay, reading number of subject. Okay, so we reflect again this bullet here, we call it a looping. Okay, it's called a looping, and this one we call a looping again as well. So when it said a tuition fee control here, we are controlling reading and also calculating a fee for the subject here. For example, we put 2 subject, so means that we are reading twice subject number 1, subject number 2. Okay, so whenever we have 2 numbers here, we have 2 subject here, we are repeating the same task for the reading here. So this is why we have what we call here is a bullet shape here that will read twice, 2 subjects, looping again. And of course, this one, let's say we have for the subject here, we have a specific price for it. Maths, let's say 50 ringgit. Science, for example, is 60 ringgit. So when it said we're gonna have looping again, and that reflect to the subject price, okay, subject fee. And then this one is a print out the what you call the output for the 2 subjects fee here, 60 together with the 50 is total up to 110 ringgit, right? Okay, print out, we don't have any looping because we print once only for the total fees for 2 subjects, right? Okay, now we have a sub level module here, and the read here that we have here is more detail. This one is simple one, okay, and this one we have, there is sub level modules under the read here. So we have 2, okay, we have 2 inputs here. Okay, so means that the user, you need to enter the level together with the subject here. There are 2 here, right? So this one is example for the OOP programming. I don't want to touch a little more on this one because you don't touch on this one in the problem solving, but you need to know what is OOP, how the diagram should be look like, right? So this is we have a control, and it's scattered around the diagram here. Control is where module 1, 2, and module 6, 7, or 7, and so on. And we have like a module 6 have interactivity back to the control back to module 6 again, and so on, right? But different with the IC here, different with the procedural programming here. Okay, it's look like only one direction. We have one direction to the particular modules, right? Okay, so this one another term. You will see again this one in the OOP subject. Right. Okay, and the last one in the introduction part of the sequential logic structure here is the IPO, and this one is very important, and most of the question is come up on the IPO. Okay, so this one is an input, processing, and output. It looks like similar in the PAC. Whenever you understand the PAC, you should understand what is the IPO, right? So this one is extend information in PAC. That's why I said and module in IC. So if you understand regarding PAC and IC here, so you don't have any problem regarding how you can extract for the IPO. So it have 4 parts as well, right? So input, processing, the module number, and also the output. 4 parts, even though we have an input, processing, and output here. So the module number here comes from the interactivity chart. Remember again in previous slide, we have a numbers on each modules, the control module, sub module, sub level module, and so on, right? So emphasizing the 3 components of problem, which is input, processing, and output, but mainly we have a 3 here. Okay, but in the IPO table, we should have 4 sections, 4 parts here. Okay, so the addition part is this one, module reference number or names, module name from IC here. So that's why you should know regarding how to develop the IC and also how you can develop the PAC solution development Okay, right now this one. So we have the input. Of course, we already talk about a lot of in input. So this one is like a data in the previous PAC and IC, right? And then we have a processing. Is there any calculations there? Okay, the module reference number, module name from IC. If we look again in the PAC, okay. So look again at PAC. This one we call as read, calculate, print is a module name. Tuition fee control here is a module name, right? Okay. So I move on the more detail on the example here. Okay. So this one is a calculate fees here, and this one example come from the IC interactivity chart that we have just now, right? Okay. So calculate fees of student in tuition center. User needs to insert level of study. Insert level of study. So means that user need to key in a data to the program. Okay, it's not the constant. It's not the constant. Level 1 is UPSR, 2 PT3, 3 SPM, 4 equal to STPM, right? So user need to enter either one UPSR, and then this one is reflect to the what you call the fee for it. And then we need to choose a subject. What subject? Let's say subject 1 is BM, 2 is BI, 3 maths, 4 science, and etc. and so on. All right. So by using the input processing output IPO table here, we need to extract this information. So try to look on the highlighted text here with the green together with the yellow background here. Okay, so calculate fees here. Calculate fee here is the output of the program. Okay, you need to put in here. All right, and then the input here, there is two inputs here. User needs to insert level of study and subject. There are two inputs. There are two inputs, and then the processing for each here we have here that reflect to the modules that we have. Okay, so level here, level of study here is insert level of study. So whatever is insert, okay, so program means that it's reading a data from the keyboard. Okay, that's why you have a module of read here. So reading, enter level, so program reading the data. Enter subject, of course the program reading the data from the user key in, right? And then we have a calculate fees. Calculate fees also the processing here. Okay, so it's reflect to the calculate module reference, or you can put here the reference number. Okay, try to look again in our previous slide. There is a numbers in the calculate modules. Even though we have a read, we have a numbers for the read here as well. And then print also we consider as a processing because it's processed in the program to print out, to display the output. Okay, this one is to display the output. And then we need to have the last processing here, which is end. So end here meaning that is one of the process that will end the program. You will exit the program. So whenever we have the end here, and then we have a complete, what you call this, a complete input process output. You already have the output. This one is the input, process, and output. All right, okay. So normally in a program we should have this kind of the elements: input, processing, and also the output. This one is very important. All right, okay. Now can you understand regarding the IPO so far? You can type down yes here in the chatting room, so I know that you understand regarding this chapter, right? Okay. So we try to give you maybe later example of the IPO questions together with the PAC and also IC for your better understanding, right? Okay, so this is another example here. Calculate average of three numbers, right? So calculate of three numbers here, right? Okay, so later in the end of the at the end of the lecture, you can try this one. Calculate average of three number without any looking on the sample solution for the IPO here. You try to do one by one and so on. Okay, either you understand regarding this one also. right? Okay, so this is another example. Try for it. So whatever is try for it, you need to try by yourself. And it's very hard for the online session here. For this one. Okay, just to give you maybe at the end of the lecture, you can try it out how you can design the PAC and also the IC for this one. There are two questions here that you can try for it. Right? Okay, so this one's already given the sample of the answer for it for your reference. Let's say for example number 1 here, to calculate, we find an area of a triangle, okay, which is the formula is half of the height and also length, then create interactivity chart and input processing output chart. There are three solution development is a PAC, IC, and also IPO. Right? So the IPO, so this one is a PAC. Okay, it's a PAC. Okay, it's not IPO, but this one is a PAC. Given data, we have a 2 height and also length. Required result is area. Processing, we have the formula and alternative solution. Then you can have a constant or you can have input values. Right? And then we have the IC here. Of course, we have a calculate area control. Here is like this program is reflect to this case study. It's calculating area, and then you put the control at the end of the control module. Reading to value, calculating of the triangle, and then output for it. Okay. And this one is the IPO, and of course this one is IPO. We have an input based looking on the PAC and together with the IC solution that we have in the previous slide, and then we can do for the IPO here. Here is very straightforward. And this one is another example that we have here by using a module number. Previously we have a module's name. If you put a number and also names here, is still correct for this one, right? Okay, so we high length. At the high here, imagine that we should have a 1 by 1 processing line. Okay, it should have 1 by 1. Okay, high, the first data, length is the second data, and then what you should do after that? Calculation, number 3. And then after you do the calculation, you display the area by using the print. Okay, the print module, which is the number is 3000 based on your IC number here, 3000. Right? Okay. Now, so this one is another example for it. You need to convert the miles into the kilometer, and 1 miles is equal to 1.6 kilometer. Okay. So remember again, this asterisk symbol here represent the best solution for this case study. You can use constant here, but it's not the best way for the program. Okay, this one is the solution for the IC interactivity chart, how you can calculate distance here, or you can convert the distance into miles into the kilometers. We have a read, calculate, and print. Normally we have these three. All right, so this one is the IPO for the second example. We have a miles, only one input, enter miles, reading. And then what you should do after entering this data of miles. Of course, you need to calculate the kilometers, 1.609 multiplied by miles, let's say 2, so and then equal to the kilometers that we have and we're handing. So module here, by using the module name instead of module number, we can use a module name, right? Okay. Right now, so far, is there any question regarding this one? Okay, regarding the PAC, IC, and also the IPO, right? So I think that one is very straightforward, and the difficult part is regarding the how we can extract the information from the case study. Let's say you have a case study from this one, and then you need to extract and then put it in the PAC, IC, and also the IPO table, right? Anything regarding this one? So if you are understand regarding this one, pseudocode algorithm, you can type down yes in the chatting. So I know that you understand and following my lecture for the first part here. Right. Okay. So there are two parts that we need to cover here. Sorry, there are four parts that we need to cover: pseudocode and algorithm. Just now we have already have a PAC, IC, and also IPO. Second part here is a pseudocode and algorithm, and then we're gonna look on the just checking, right? Just checking, and the last one is a flowchart, right? This one is very important for your mini project because you need to have all these things in the mini project in order to develop a program, all right? So normally you should develop this one. What I mean is that you should have this solution development by using PAC, IC, and IPO, pseudocode and algorithm, as well as a flowchart in order to develop a programming by using a programming language. Okay, like it's not only C programming, you can use in Java programming, C++, whatsoever. So you know that. So this is the flow of your program later on, right? Okay. So I move on the next part here, which is pseudocode and algorithm. So this one is you should able to use pseudocode and algorithm to develop the instruction for each module in the solution of a problem. Okay, so there are different things in the pseudocode and algorithm here, but it looks similar. Looks similar. I can say that pseudocode is more likely like coding. Okay, like coding, and algorithm I can say that it looks like English daily words. Okay, for example, enter two numbers. Okay, display the result of two numbers, for example. So that one we call as English word, but in pseudocode we call it something like read num1 num2, for example. Okay, calculate this number and so on. So it's more likely programming in the pseudocode. Okay, now, so what is pseudocode here? Okay, it's a list of instructions to solve tasks. Similar we have here in the what you call the other things there. Okay, list of instruction to solve a task. And then it's a formal way, informal way to design of computer program or algorithm. Okay, so informal way, so meaning that it's up to you either you want to use pseudocode, an algorithm, so it's up to, but you need to understand regarding these two technique here, pseudocode and algorithm, how you can develop these two. Okay, so there are three standard rules to produce pseudocode. Dia ada tiga. Okay, tiga syarat, three conditions. So each instruction have number to enforce ordered sequence of operation with subordinate. For example, 3, 3.1, 3.2, 4, for example, and so on. Okay, you should have numbers in the left side of the procedure. And then we have each instruction should be clear, right? It should be clear because you're gonna pass this pseudocode into the developer later on. So developers see that if you don't have any clear instruction, you don't have any clear procedure in the pseudocode, it may have difficulty for the programmer to understand your pseudocode. And then you must have completeness to ensure nothing is left out. Okay, if the pseudocode should have three values, okay, you should put three values, don't put one values, two values. It may have something what you call missing data in the pseudocode. Okay, so this is example of the pseudocode that we have. Okay, with more detail you can try to retrieve, you can visit this website, retrieve from this website. There's a lot of the sample of pseudocode inside it. And then there was an example for the computing sales tax. Pseudocode the task of computing the final price of an item after figuring in sales tax here, right? So the example here. So note the three types of instruction. Read equal is a process. Okay, output is also a process as well here. So read, print here is the standard words that you should have in the pseudocode. Or another word that we have read here, we can use get, G-E-T. So meaning that is the user must enter a number. User must enter a data into program. Okay. Print here is another one here that reflects to the display the output. Okay. And then if you read, if you see here, okay, line number 1 we have start, and also line number 7 here we have an ending. Of course, you need to have a start instruction and so on the end instruction for the pseudocode, right? Okay, so then we have variables that we have here. Okay, you should put the variables. What are the variables that reflects to this case study? Okay, price of item, sell tax rate, sales tax, and also total price. It should be inside this algorithm. Okay, for example here, price of item, this one. Okay, sell tax rate, okay, this one, sales tax, this one, and total price is this one. Okay, whatever you put this variable here, it should be included in the pseudocode. Don't put the variable that doesn't been used in the pseudocode. That's why it's called as a completeness. So the programmer may see that I see that there is one additional variable here, but doesn't been used here. Is this pseudocode is not complete? So this is what we call is the completeness. Okay. If this one here we have a 4 variable, and then inside here we should have 4 variable, right? Okay. Now, so this is example number 2 here. Okay. So this number 2 here is reflect to the numbering for line number 4, and then we have a sub line of the line number 4 here is 4.1. Line number 5 we have 5.1. So meaning that 4.1 and also 5.1 here is being grouped in one line. Okay, it reflects to one line here. So if our work is less or equal to 30, then so you do this statement, right? Okay. So this one is a pseudocode, the task of computing gross pay given pay rate and hour work, right? So this is an example that we have. And so these are the variable 1, 2, 3. 1, 2, 3. Don't put additional variables without using it in the pseudocode here, right? Okay. So you can see this one is more detailed regarding in this website, right? How you can develop the pseudocode for it. Okay, so we move on the second part in this one, right, which is the algorithm. Okay, we can see that it's also an ordered sequence. Okay, in pseudocode we call it a list of instructions. Okay, sequence and instruction. Here is different instruction here, something like instruction for the coding. Okay, so an order of sequence here is looks like a step by step as well. All right, and I can say this algorithm is reflect to English word. So it's doable. So doable means that it can be done in the programming. Okay, it can be done in the programming. So can be done without difficulty. Okay, without difficulty. Whenever this you type down the algorithm in English word, the programmer understand this English word and can be present in the pseudocode and then later on in the programming. Okay, and it's perform some tasks. Okay, some tasks for an algorithm can be executed by a computing agent, which is not necessary a computer. Okay, what I meaning is that algorithm. So we can design algorithm here, for example, how to prepare a good recipe for cookies, for example. This one also we consider as a algorithm because it's an order of sequence, right? If you go look on the what you call it recipes website, they give you step by step. Step number 1, what should you prepare? 2, 3, 4, 5 until it's baking the cookies, whatever, and so on. And this one we call it as a not necessary for the computer. Okay, not necessary for the computer. Okay, for example, this one is a properties algorithm. It should have the input, output, and also the effectiveness. In the pseudocode, we have the completeness. It should have a complete variable, should have a complete process input and output. And then this one we call it as effectiveness. All operation must sufficiently can be done. It's doable. Okay, it's doable. All right. So input here, algorithm needs to have 0 or more input from a set of object. It doesn't have any input, and then you can do the process later on and so on. And then output here is a processing. Must have at least one or more outputs that relate to the input. Right? Okay. So what is the what we call the problem versus an algorithm here? Okay, each problem can have many algorithms. Right? One problem can have many algorithms. Let's say, for example, okay, let's say, for example, how to prepare a good cookies. Okay, some chef, okay, they have this kind of the recipes. Algorithm number one. Chef number two here, this is the instruction is for preparing a good cookies, for example, algorithm number two, and so on. Okay, so this we call is we have many algorithm in order to solve one problem. Right, so common element of algorithm here that you need to have a data or input. Calculation is a processing as well, and also result output. And this one is very clear enough because we already talked about input, process, and output in the previous slide, which is in the PAC, IC, and also IPO. Right, so what is the category of algorithm operation here? We have a sequential. Right, sequential means that the instruction is being executed step by step in order. Okay, 1 2 3 4 5 6 7 and so on. Okay, so we have another one. The second one here is decision. Okay, decision. So choosing among two or more action based on the input data. For example, here we have, let's say you want to do KL, or you want to do, okay, you want to go to KL, or you want to go to Terengganu, for example. Okay, for example, okay, just to give you some example, let's say you want to go for holiday. Okay, and then this one is considered like is there, is the state is being PKPD or something, then you can go away and so on, and then it's decided based on the input. Okay, if the Kuala Lumpur, you say you want to go Kuala Lumpur, they should have additional what you call options. Okay, the options that you want to go for KL, as you want to go for Terengganu, Kelantan, so on and so on. So if Kuala Lumpur is being PKPD, and then go to the other state, let's say Pahang, Johor, Melaka, something and so on. Right, and then the last one we have a looping here. Okay, execute repeated a set of instruction. Okay, it's a set of instruction until logical condition holds. All right, okay, let's say you want to enter number. Okay, enter number, we call it a sequential, but enter uh, 5 numbers by using a looping here. You enter number 1 2 3 4 5 until 5 here, we call it as a condition that has been made in the looping. It will exit the looping. So here they call it as a looping. Execute the same task. Repeated a set of instruction. Reading a number is an instruction, but it will keep repeated until 5 times. 5 times here is a logical condition holds. Right, so this is an example of in a daily life, right, making a cake. Siapa pernah buat cake sebelum ni? Ada yang pernah buat cake ke? Right, so you may try to use these recipes in order to make a cake. Right, can you see from this example here, it looks at English word in daily life. Okay, put 5 eggs in a bowl, add a cup of sugar, stir, add a cup of buttermilk. Right, so many times this one is step by step, is very clear. Okay, is clear enough for the other person to refer this algorithm to make a cake. Right, let's say you don't have any line number 3 here, stir here, just add a cup of buttermilk. You don't stir, just put it in there and so on. You don't get a cake, you may get a different kind of the cake in there, something like that. All right, okay, So set the temperature, what set temperature into what kind of temperature, set the timer, how much, 15 minutes, whatever, temperature, 150 degrees Celsius and so on. So this one we call it a step by step. It's instruction of the ordered, okay, 1 until 12. Okay, and then you have a cake here, right? Okay, so in a computer, we can have something like this one. Okay, you can have something like this one. Algorithm. Find an area of circle. Find an area of circle. Remember that algorithm is reflect to a specific task, right? And this task is to calculate a circle, calculate an area of circle, right? So line number 1 here is we call as a module name. Remember again, we have a control module, control module. So this one here, calculate area, okay, calculate area, and then we have the variable name, and then we have the value in the module. Then we have a read area equal to radius and so on. Okay, right? Name of algorithm. So we should end is complete. Inside is the process and output, right? Okay. So far, is there any question regarding pseudocode and algorithm? Later, if I have time, I will try to share with you different kind of the example for the pseudocode and algorithm for your better understanding. And I will try to give you certain question that reflect to this subtopics. All right? Is there any question so far? You can type down in the chatting there. Yes, and we can try to continue in the test checking. All right. Okay. So I proceed on the second last year regarding the desk checking here. All right. So desk checking here, let's say you have a desk here, then you already have some kind of the report. Okay. You need to check the report that have in your desk here. So meaning that, okay, you already have a PAC, you already have an IPO, you already have an IC, you already have a algorithm, and then you have already have a pseudocode here. Now this step is you need to evaluate your algorithms. Okay, you need to evaluate algorithms. Why you need to evaluate algorithms? You evaluate the algorithm to make sure the effectiveness. You should have a complete program for it. Is there any mistake in the algorithm that have an error when you do the test checking here, right? It's like you are checking one by one in terms of the input, process, and the output in the test checking, right? So the aims of this subtopic here, students should understand how to run the algorithm manually. All right. So when you say you can analyze the algorithm, let's say I give you the algorithm, try to evaluate this algorithm or test this algorithm by using the test checking. Okay. Now, so what is test checking? So this one is we call it a tracing. Okay. We are checking through the logic of the algorithm with some chosen test data. Chosen test data, we can have different kind of the data. We can try this number and then we do the checking, is it correct, and then we try again with the other numbers. We do the checking again, is this the answer is correct, and then we may have another numbers here for the last one, do the checking, and then it's correct. So we have a checking here. Once you have the checking here, so we can consider algorithm, your algorithm is good, okay, is effective. To test the correctness of the algorithm, of course, this is the purpose of the test checking here, to test the correctness. Okay, you might have this, you have a missing variable, will affect the result. It's not complete. Okay, To test, please ensure the algorithm have the line number. Okay, so your algorithm should have the line number. Okay, so this line number will be used in the test checking for the evaluation part, right? So step in test checking, this is 6 steps here. Choose simple input test case that are valid. All right. If the valid number is a let's say for example is integer, then you use an integer. If the valid number is a real number, floating number, then use a floating number. Then establish expected result for each test cases. Identify the relevant variable names within the within the algorithm. Okay, you should identify what are the variables in the algorithm. Remember that in our pseudocode we have it. This we call the variables there fixed for in the pseudocode. Repeat the process until the other test cases until algorithm has reached its goal, logical. Okay, check that the expected result established in step 2, okay, expected result match the actual result developed in step number 5. Okay, developed in number 5. If the expected result here, let's say adding two numbers is 2, 1 plus 1 is 2, expected is 2, so supposedly you have a 2 here, the result of 2 here in step number 5. Right, so this is an example of the test checking, right? This example of test checking of circle area, and this is one of the example of the algorithm. It should have the line number here, and this line number reflect to the test checking. Okay, right? So line number, this one, make sure your algorithm have line number, then set column 1 as line number. Okay, the last column here, make sure the last column here is the input or the output. Okay, input, output later on, how we can present the input and how we can present the output in the same column, right? The middle here is the variables. Okay, you should understand where is the variables being used in this algorithm. Radius is the algorithm. What else? Pi here is constant. The pi here is the constant. So it's not considered as the variable. Okay. Radius here is a variable. Okay, this one. Area here also the variable because it depends on the radius that we have here. Okay, it depends on the radius that we enter, that we read for the program. Okay. So pacing algorithm lists all variable. Each variable have their own column. One column for one variable. Radius one column, area is one column. Okay. So for decision and looping, then we have this one, the last one here. All right. Okay. So we're gonna use a set of data. Okay. Set number 1 and also set number 2, which radius equal to 2 and also radius equal to 3. So we're gonna try out this checking in order to make sure the completeness of this algorithm. Okay, so first set, this one is the first set and this one is second set. So we're gonna have here line number 1 until 5, line number 1 in the algorithm and until 5 in the algorithm. So line number 1 here is the algorithm name. So you don't put anything in line number 1 here because it reflects to the variable name. Okay, it's a variable name. Okay, so line number 2 here, read radius. Since the status data is a 2, then you put this one is radius equal to 2, meaning that 2 being assigned in the variable here. Right? Okay, so this one is a radius. This one, okay, radius. Okay, radius. Question mark here is reflects to the input. Okay, symbol question mark here is input, and this is a calculation that we have here. Area equal 222, and then pi here 3.142. Line number 3. Line number 4 is print area, is the output. 12.568 is the output, and the last one here is n. You don't have any n here, right? Okay, So far, is there a question? Can you type down in the chatting so you are following my lecture for this one? All right. Okay. So can we take a break for 5 minutes and then we continue again? We take a break for 5 minutes, right? Hello, Assalamualaikum. Are you there? So we are about to start again our lecture. We continue. Right, okay. So Assalamualaikum. We continue again with our example number 2 on the test checking here. We have two sets of data. Set number 1, we have we call is equal to 4, h equal to 5. All right. So example number 1 here, they say we have how to calculate an area. Of course, we have two set of numbers, 2 and so 3 here. And try to look on the what is step line by line that we have. And then, for example, we have set number 3. Okay, radius equal to 3. Let's put the radius equal to 3 in this one. Okay, if you have you see in this algorithm there is one additional variable, just put one column here and then what are the values that are being changed in the variable, right? So radius here, question mark is 3 reflects to the input. So this is the way that we need to have here, okay, to differentiate between input and output. This one is a input and 12 and 5 is here directly the output. Here this we call as output. Radius question mark 3 here, this input. Okay, right? Then we have the output and what's the area for it together with the calculation. Okay, so there's an example number 2 here. You can try to look for it. Okay, what's happening in the test checking and what is the given algorithm for this one. Okay, right. So this one, another example regarding this one. Okay, so you may try to use the test checking here to calculate discount price. Okay, even though you can just read from this algorithm, and then you get the expected output for this algorithm, calculate discount price. Okay, so what later on, what is you need to do is then try to develop the test checking by using this technique. Okay, identify how many variables that we have here. Okay, so what is the input and also what the output, and then what is the expected output from this algorithm. Okay, so this is a sample of the test checking, right? So test checking here that we have. Okay, so since we have here line number 2 here, let's say line number 2 here, try to look line number 2. Line number 2 here, input discount percent and also price. There are two inputs here. In the column here, we have two columns that reflect to the input, discount percent and also the price. So you put two numbers here, 10 also 200. So in the input output column here, you put two elements, price, okay, semicolon, discount percent, question mark, 10. So this is the way is how you can present the input in the input output column, right? So the rest is just similar with the other example 1 also example number 2. Okay, right. So this part is on how we can test the algorithm by using the test checking, right? And this one is the flowchart. The last subtopic in this topic, number 3, sequential logic structure. And the student should know how to sketch and construct the symbols in flowchart. All right. So there are certain symbols that you need to understand and you can apply in the flowchart development. Apply the guidelines in drawing flowchart and design the problem solving by using the flowchart. Right. Okay. So what is flowchart actually? So flowchart here is a graphical representation that represent the symbols and they have a connecting lines in the flowchart. So let's say symbol number 1, 2, 3. So like symbol number 1 connect to symbol number 2 is a meaning that there is some connectivity between 1 and 2 then. That is the alternative method of representing algorithm. That's why I said in the programming, there is we call a solution development. There is a certain case that you should have the flowchart. In a certain case, you should have both of it, let's say algorithm and flowchart. Pseudocode, flowchart, and algorithm, and so on. So meaning that there is the certain ways that represent the algorithm. Another one is a flowchart here. But since you are taking problem solving here, you should know what is flowchart, algorithm, and pseudocode as well. Okay, so this one is easy to learn, intuitive method for to know the flow and algorithm, because it's more on graphical representation. And since it's graphical, it's like we look on the diagram, we look on the flowchart, we can see the whole structure of the program. Okay, okay, it's a graphical representation, show the logic error, right? So testing from a set of data. Okay, so the goodness of the flowchart here, we can see the what we call the errorness in the flowchart here. Let's say we have a conditions. Okay, you want to go here, there, and so on. You have a condition. Remember that in the interactivity chart, we have a diamond shape that represent the condition. So we can represent this condition in the flowchart as well. Okay, so there are certain symbols that you should know, right? The flow lines. Okay, we have end, start, or we call it stop and exit. Okay, process. This one is symbol. And then we have a processing. The rectangle show processing such as calculation. Okay, the output also we call it as a process as well. Okay, so this one, okay, this one is a parallelogram to that show input to output. Okay, so this one is a process. This one is a process. Okay, calculation, whatever, and so on. This one is the input and output. We call this a parallelogram. Okay, show input and output of the memory. Okay, so input and output sharing the same, we got the same shape here. And then we have a decision. This diamond indicates a decision. It has one entrance and two exit from the block. Okay, yes or no. Okay, do you get the good result? Yes, then go to this direction. If no, go to this direction. Okay, for example, do you pass problem solving this semester? Yes, and then you can take programming technique for the next semester. Otherwise, you need to retake again problem solving. Okay, so this is another one. Here is a process module. Okay, rectangle with line down each side shows the process of module, one entrance and one exit. So this one is a counter looping. So we have ASP that represent the counter, increment, and also the conditions. Okay, right? So the starting value and the increment, and then we have an increment, and then we have the conditions. Okay, another one is a one page connectors. The circle connect section on the same page. The same page. Okay, let's say you have a one what do you call it, the process, and then want to connect to the other modules. Okay, in the same page, you're gonna use this circle. Okay, so if you have a what you call that flowchart, it's being separated in different pages. So you're gonna use this one. Okay, this symbol. For example, like this one page connector, one page that A is connected to this diagram. Okay, you draw a diagram and so on. It's not being something like, it's not what we call, it's not enough in, it's not good enough represent in two pages, but you want to do in one pages only. You can try to this one. Okay, let's say you want to do in two pages using this one. Okay, this shape like this one. Okay, so page one of two. Page 2 of 2. The second page is first page. Okay, so this is a basic control structure in the flowchart. We have a sequence, decision, and looping. The difference here. So sequence here we call as a straightforward, one by one. Like for example, we have a recipes here. Step 1, 2, 3, 4, 5, 6, until the last step here. This one is called straightforward. You don't go back to the other what you call the previous step. Okay, you don't go back to the previous step. Okay, so that's one is the sequence. So sequence used to represent basic computer operation, receive information, put information, profile arithmetic, and also assign value. This is straightforward. For example, like diagram here, we have three statements: A, B, and also C. Must execute one by one. You don't execute B first. You don't execute C first. Okay, you should execute A first, B, and also the last one is C. Okay. So how we can do for the sequence here? This is an example, all right? For the from the algorithm, find volume of a problem. Begin this one, and then we should enter length, width, and the height here. So this is the representation in the flowchart by using a flowchart, right? So we have here this parallelogram for enter. Parallelogram also this one input. This tree is input, and then we have a rectangle shape here that represent the calculation or the process for this algorithm. Display volume here also we are using the parallelogram as well because we are using the same shape as the input. And then between of this input and process and output here, you should have we should wrap this one as a starting and also the end shape, start and also the end. Okay, this is another example for it. Okay, we have like this one. Okay, for example, let's say we have a we have a flowchart here. Represent this one into the algorithm. Okay, we can have enter one, now two. So here we can read one, read two, example and so on, and then you do have a calculation, display sum that reflect to the flowchart here. Okay, so this one also important regarding the decision is a presentation of the what we call the options. Okay, a condition is depending on either side of true or false, right? Like this one, condition P, is it true? It's true, and then we do the statement A. If false, then we do the statement number B. Imagine you are past this subject and it's true, and then you can take programming technique in the next semester. Otherwise, it's false, and then you should retake again the subject for the next following semester. Okay, and then for problem solving, you should the passing mark is 50%. Decision example used when a task is performed only condition is true. Okay, null else as construct has no processing in the false mouse. Okay, the null else structure like this one, for example, if condition is false and then it will exit the statement. Okay, it's true and then it will go like this one. Okay, so when this you only have the one statement in the condition if here, if this one is true, false otherwise it will exit the program. Okay, so you will see more detail on this one in the looping and also decision when you do the programming part later on. Okay, then you can see how the presentation of the decision in the programming. And the last part here we call it a looping here. Okay, it's looping is a set of instructions to be performed repeatedly as long as the condition is true. Okay, selagi mana condition is true and then it will keep again loop again and again. So when condition P is false, control will pass out the repetition structure down to the false path. All right, for example like this one. Okay, so condition we have P, it says true, and then loop again, loop again, loop again until the condition is false. Okay. Okay, so this is an example of the case study for the sequential logic structure that wrap up all together from starting PAC, IC, IPO until the flowchart. All right, so this is an example of the case study. Change the Celsius temperature to Fahrenheit. Try to solve this problem by using a PAC. Okay, so you already learned regarding the PAC. All right, there are 4 sections in there. The interactivity chart that reflects to the modules diagram, input, process, output. Here there is 3 main part, which is the input, processing, output, and then we have additional column that we call as the module name or number, right? And then we go for the algorithm and pseudocodes. Okay, how you can present the case study, how you can try to solve the problem by using the pseudocode and algorithm. And just checking here how we can test the algorithm, okay, by using this checking with a set of number or a set of data to make sure the completeness of your algorithm. And then we have a flowchart here. There is a lot of symbols that you should know. What are the symbol for the input, output, process, decision, looping, and so on. Okay, right? So this is kind of the example. for PAC and IC, right? Okay, so you may continue the address regarding the input IPO, okay, the algorithm, desk checking, and the last one is the flowchart. All right, so you can try this one. Okay, you can try this questions, and we try to discuss in our lab session later on. Okay, I will try to remind you again. Try to do this one for the IPO algorithm, just checking and flowchart for this kind of the case study, right? Okay, so before I end our virtual lecture today, so you already learned regarding what is sequential logic structure, and this one I can say that it's very important to have a good logic in the programming, okay, in order to try to solve the problem, right? And then you already learn how to present the solution development by using PAC, okay, program analysis chart, interactivity chart, and also input processing output chart. Okay, and then you already learn how to create an algorithm for sequence logic structure. Okay, and then how you evaluate the algorithm by using the test checking. And test checking here, you must know how to extract the variables that exist in the algorithm. Okay, and the last one is the basic concept on the a flowchart, and you need to know how what are the symbols represent in the flowchart. Okay, and then how to design a flowchart for the case study. All right, okay, so now, so that is the end of our lecture today. Okay, hopefully you understand regarding my lecture. You can type down in the chatting there, either this session is giving you more understandable regarding topic number 3, sequential logic structure. Okay, and otherwise we can try to have more discussion again in our lab session. Okay, so regarding the lab session, I will try to inform again, and inshallah by today or tomorrow what you should do for the lab session. All right, okay, so far is there any question regarding this one? Okay, you may type in the chatting before I end our session today.
Thank
Ada
you.
soalan?
Thank you, madam. Thank you, sir.
Yeah, any question so far? Any question so far? No. All right.
Thank you, sir.
Okay, so we'll try to prepare something material from the previous midterm or final year that reflect to this topic, all right, to make sure that you are ready regarding this topic. Okay, so because this one is very important, right? Okay, so then later after maybe after 1 hours, I will try to share our recorded session to make sure that those who come late or cannot have internet connection can watch again my lecture today. All right, thank you very much and see you by this Friday for lab session.
Thank you, sir.
Sama-sama.
Sir,
Yes.
our quiz kita nak jawab dekat kalam ke?
Okay,
Atau
before I forget, quiz will be open in our Kalam, right? And then will be closed by this midnight, 1 minute before midnight,
okay.
11:59 p.m. Okay, it's 10-minute duration. It's very easy. Okay, if you do the lab exercise before, it's very easy.
Okay, sir. Thank you.
All right. Okay.